Hi Calculus 1 students. So this is the last example in the 3.6 section, derivatives of logarithmic functions. And I would highly encourage you to do it by yourself, this one. And okay, so I'm gonna just tell you there's like a trap in this question that some of you might fall into if you do that number by yourself. But I do want this to happen because if it happens now, like you're gonna realize it and you're not gonna do the same thing in an examination. Okay, so I strongly encourage, please differentiate this by yourself and then watch this video to confirm your answer, because it's a mistake. Like this derivative like has a tricky part that we trap a lot of students into. Okay, with that in mind, let's show this derivative now. Okay, so we just need to differentiate this. And look, it looks so easy. It looks easy. But that's also why it's hard. It's because like it can catch some people by surprise. So the derivative, the first step, well, the first step is the preparation step, but remember, there's actually nothing to simplify here. Okay? And the second step is to use the quotient rule. So in other words, we're gonna have the derivative of the top times the bottom. Okay, so 1 plus x to the power of sine of x. Okay, then minus the top times the derivative of the bottom. And the derivative of the bottom, as you can see, will end up being the derivative of x sine of x. Or actually, should I write everything down? No, let's just write like x sine of x prime. Okay, and then this is divided by like that's it, so the bottom squared, so x sine of x squared. Okay, I want you to note that I did nothing else than the quotient rule here, and I said that the derivative of 5 is 5x, right? So let's just take note of that. That's the only single thing I've done, so it's very far from the final answer. Now, where is the tricky part that we trap our students is exactly here. Okay, so I've seen a lot of students in the past trying to invent a derivative rule for that because they need to go forward, right? But it's not the right thought process. So I'm just gonna outline like a couple of things that are wrong. So some people are gonna do like sine of x times x to the power of sine of x minus 1. Okay, and this is not valid. Okay, the power rule is not valid. So let's just write that down. Power rule works only when exponent is constant. Okay, now I've seen some students as well in the past doing stuff like this: x to the power of sine of x prime. So okay, it's an exponential function. I'm gonna write here x sine of x multiplied by ln of x times the derivative of sine of x. Okay, so in other words, they're using the exponential rule, which is also wrong. The exponential rule works only if the base is constant. So exponential rule works only when base is constant. There you go. Okay, and I've even seen some student trying to mingle the two together, which is typically failing, okay, because it's actually the conceptual leap to do here is to realize that this has to be done by logarithmic differentiation. Whenever you have a function to the power of a function, that's what you need to do. So let's actually just recap that. Okay, so for functions like I'm gonna say here f of x to the power of g of x, we need to use the technique that we've learned in this section, which is called logarithmic differentiation. Use logarithmic differentiation. Okay. So how can we do this? Because this is like stuck in a big derivative. Well, the idea is just to do it on the side. And once we have the result, we will replace this by what it should be. Okay? So let's actually write here on the side. So on the side. Okay? So I'm going to use another letter instead of y. I'm going to use I don't know what I can use. I can use, let's say, z. Okay. Let's have a variable z, which is x to the sine of x. Logarithmic differentiation, remember that what it tells you is to drop logarithms on both sides. Okay. So ln of x to the power of sine of x. And what it allows you to do is to send the sign in front of the logarithm. So you have here ln of z, which is equal to sine of x times ln of x. Okay. And, okay, perfect. Now, from here, let's actually move back on top here. We're taking the derivatives of both sides implicitly. So, and be careful because implicit differentiation is something I see a lot of students have trouble in, because remember that z is a function of x, right? So z is a function of x. It's the inside function, okay? And for that reason, we have to use the chain rule when we do the derivative of ln of z. So in other words, derivative of the outside, right, 1 over, stick the inside in, z, and then multiply by the derivative of the inside, which is z prime. Okay, so z prime of x. Then, on the other side, you simply use the product rule. So that part of it is simple. So the derivative of sine of x is cos of x. So we're going to have cos of x ln of x plus sine of x multiplied by the derivative of ln of x, which is 1 over x. Now, obviously from there, you solve for z prime. So in other words, what you have is that z prime. So let's actually keep the color code because I do want to draw your attention on something. Is that as we send z on the other side, we're going to replace it by what it is. We're going to replace it with x sine of x. And finally, we just multiply by all of that. So x sine of x multiplied, and I don't want to draw your attention on the product rule anymore, so I'm just going to write it all in blue. There you are. Okay, so this is the z prime. And now we're almost done the problem, but we need to erase this part and we need to continue from here. So let's actually write here from the on the side calculation. Which is actually what I would expect you to do on a test, right? And okay, so let's just leave in blue anything that doesn't change. So x sine of x minus 5x. And now here's the deal. You're going to replace this by the result. Okay, so this turns out to give you this. X sine of x multiplied by cosine of x ln of x plus sine of x over x. Obviously, dividing this by the 1 plus, so I'm actually going to send this back on top now that I see that I'm cutting it down. So there you go. Here you have your sine of x over x, close bracket, and then multiplied by 1 plus x sine of x, all of it squared. Okay. Now, at this point, you can simplify a little bit by combining the exponents here. But in reality, I would prefer you not to. So I prefer if you, in this kind of problem where you just differentiate, rules of exponents are fine, but only if you're very confident in them. So I would accept this as a final answer. All right, I hope it was helpful. So see you in class or in the next video.